What is classification? Can you imagine if the store was not classified? How would you ever find anything that you're looking for? Classification is all around us. What is classification? Well, where am I? This is a perfect example of classification right here behind me. So what is classification? So now I'm in the laundry room, and you ever have to do the laundry, or at least when the laundry's done, take it out of the dryer, fold the laundry, put it in different piles. These are my socks, this is Dad's shirt, these are Mom's pants. Right? That's classification. Or take it into your closet, and the socks go in one place, the shirts get hung up somewhere else, or the pants. Right? Those are examples of classification. Classification is the grouping of events or objects based on similar properties. So you look at their similarities. Oh, this is my size shirt. Right? So they all go together and they're different than Dad's. That's classification. Classification is important in science in general. You probably learned about kingdom, phylum, right? Classes, families, when you're organizing animals in living life science. Earth science, we classify all kinds of things. Clouds have different categories. Planets, you may have heard a few years ago how Pluto got demoted to a dwarf planet. Stars are grouped based on their characteristics. There's dwarf stars, there's red giants. There's all kinds of ways that scientists classify things. Rocks. Are you familiar with the three general ways that scientists classify rocks? Igneous, metamorphic, sedimentary. So classification is very important. It makes it easier to study things, to analyze based on their similarities. Okay, so next I ask you, what is an observation? Can you give me an example of one? All right, so I'm hearing people talking about things they see. The grass is green. Somebody said something about they saw somebody move behind me. Those are examples of observations, but those aren't the only thing that observations are. Did you hear that? All right, I hear a cowbell. That's an example of an observation. So let's broaden our definition. What is an example of an observation? You can see an observation, you can hear it. All right, so an observation is when you use your senses to gather data, to gather information from the environment around you. All right, now, how many senses are there? Good, there's 5. All right, so what are the 5? You can see, you can smell, the 2 S's. You can taste, you can touch, the 2 T's, and then you can hear. So there's 2 S's, 2 T's, and an H. Okay? Making observations is also known as sensory perception because you're using your senses to gather data. And with humans, our senses are not always that reliable. So, like, perfect example is our sight. I can only see so far. So if I want to see that bird up in the tree, what I have to do is I have to use my binoculars so that I can extend my senses to see even farther. Binoculars are an example of an instrument. They extend your senses. And just with sight, binoculars are not the only instrument. Some people have glasses, some people have contact lenses. Some people, when they want to look at cells inside my hand, will use a microscope. Some people that want to look at galaxies far, far away will use a telescope. They are all examples of instruments that can extend your sense of sight. And those, of course, are not the only examples of instruments because people have hearing aids to extend their sense of hearing. In earth science, you're going to use a thermometer because people are not really good at telling temperature. So we use an instrument of a thermometer to extend our sense of telling temperature. A stopwatch, wow, that person's fast. We're not really good at identifying that. Use a stopwatch, that instrument will give us an exact measurement as to how fast someone was. And then 2 other ones I want to note that you'll hear about this year. Geiger counters are used for detecting radiation, and seismographs are useful for detecting earthquake waves. Because again, people are not really good. Ooh, big earthquake, the ground shook a lot. Well, the seismograph can extend our sense and give us more information on it. So my last question for you today is, what is an inference? An inference is an interpretation based on observable properties. So you make an observation, and then your brain interprets what you are sensing, whether you see it or smell it, taste it, touch it, or hear it. So your brain goes, jigga, 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 I think, and it interprets the data. 4 other terms for an inference, like synonyms, if you will, are an interpretation, a conclusion. So you made some observations, and now you draw your conclusion. Your brain takes the data and goes, I think this. That's a conclusion. Also called a hypothesis, which we use a lot in science. And then some people know a hypothesis as an educated guess. So those are synonyms for an inference, right? An interpretation. So let's give some examples. All right, give me an example of an inference. Well, if you look behind me, all right, somebody can make the observation and say they see a snowplow over there. All right, now that would be an observation. I see a yellow snowplow over in the bushes. All right, but an inference is your brain looking at that and going, chicka, 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 I think Mr. Oliver plows his driveway. I think Mr. Oliver has a snowplow that he uses in the winter. Now, you are making an educated guess because you see the snowplow, you know that we live in the North Country, so you make that guess. That may not be true. All right, that is your guess, that's your interpretation. That, you know what, that may be my neighbor's snowplow and I let him store it there. All right, you don't know that for sure. All right, how about over here, observation. You see a wood pile, that's an observation. Okay, now your brain looks at it and goes, I think, okay? And then now you come up with an inference. Oh, there's a wood pile. Mr. Oliver burns firewood. That's an inference. Now, you didn't say I think, but really that's what you're saying. I think Mr. Oliver burns firewood. That is an inference. Right? You don't know that for certain. Just because you see a stack of firewood does not mean that. Right? I could have cut that down and maybe I'm selling it. You do not know. So what must happen for an inference to become a fact? What has to happen so that you know that's a fact? No, I know that for a fact Mr. Oliver burns firewood. Well, you need additional data. You need to gather more evidence. You need to maybe conduct an experiment or something to gather more information that's going to corroborate your inference. So maybe you check out my house and start looking around until you find a wood stove. Maybe you come back in the wintertime and notice that some of that wood is gone. You go in my house, in my garage, and you see a stack of wood. You see smoke coming out of a chimney. Right? You gather additional data until finally you say, oh, I know for a fact Mr. Oliver burns wood. Observation versus inference. Very tricky sometimes.